Awesome. So welcome, everybody. Last talk of the day, and thank you for your patience while we played with projectors. It's 2022. You'd think it was a solved problem, but that's how these things go.
It's solved for Mac, apparently.
So, Georgios.
Hey.
Hey, how's it going?
Good.
So you know how you told me about Quarkus a while ago?
Yeah.
Yeah, I went back and I took one app and I converted it to Quarkus and I put it in production. And then I took another app and I converted it and I put it in production. And now,
easily.
Yeah, and we've done the whole estate. We've got 300 apps in production. It's going amazing. Where our cloud costs are lower, our developers are happier. In fact, it's going so good. We have a problem.
Oh, what's that?
We got acquired. and our new CEO, he's a little bit of a character.
What kind of character?
Well, he's got some requirements for how we should be doing things.
That's how it all starts, isn't it?
Yeah, and they're not ones I've seen before. And in particular, he's got some ideas about how we should do observability.
Unique ideas?
Unique ideas. And he wants them done tomorrow.
Well, that's better than yesterday.
That's true. Across 300 applications. So, since you helped me out so much last time, how do I fix this?
Well, I would say Quarkus extensions to the rescue.
Ah, cool. So, I guess, like, is there an observability extension?
Well, yeah, I mean, I don't know what the requirements are, but we have a lot of out-of-the-box, I don't know, like open telemetry.
Oh, no, open telemetry, it's not what he wants.
Micrometer.
No.
Open tracing, Jaeger.
No, he's a bit more specific than that.
Okay, so it seems like we're going to need some kind of custom solution.
Yeah, so extensions, eh? So I guess, hands up if this is your first Quarkus talk of the day. Hands up if you've been to other Quarkus talks of the day. Oh, good.
Excellent.
It's always sort of reassuring to just do that,
to
check
see if
some.
the sum match is 100%.
Yeah. So I think this will be quite familiar to you, but just to refresh, we have Quarkus Core. And then there's a whole bunch of libraries out in the world that we all love. Netty, JAX-RS, Hibernate, JWT, Elasticsearch, gRPC, whatever. And just because I'm using Quarkus doesn't mean I don't want to use all of those other things. In fact, I definitely want to do them. So I want to connect them in. But when I connect them in, I don't just go straight in. I have an extension that acts as a bridge between Quarkus and the other things.
Very true.
Yeah. And this is sort of for lots of things. And we call this the Quarkiverse. And so the next question is, why would we do this? Netty was pretty good. gRPC is pretty good. And to think about why we want to do this is we're sort of going back to, why are we even using Quarkus? What's special about Quarkus?
Right. So that's yeah. I'm sure like folks heard like a lot of Quarkus stuff, but let's just recap and explain like why this information is important for Quarkus extensions. So as you see here in the slide, the usual way that traditional frameworks that I'm not going to name, but you can like use your imagination, work is that at build time, all they do is like invoke your build tool to package all your code, right? They don't have any logic at build time. And everything that the framework needs to do is done at runtime. So like class path scanning, I don't know, file parsing, metadata generation, whatever. All that stuff is done at startup time, right? That's the traditional way. It's been around forever. It's worked great so far, but it has some inherent limitations that it takes up a lot of time to start, takes up a lot of memory that costs now in the cloud native age. So what we do with Quarkus is we try to move as much of the processing to build time, right? So all the class path scanning, all the like checking annotations, all the parsing of persistence, XML files, whatnot. All that stuff is done at build time. So we create an optimal, let's say, jar file in most cases, or a native binary. And at runtime, all that the code needs to do is like just run a few steps with all this pre-built information that we've obtained at build time, right? And that has a lot of benefits, like you already explained, and like folks have already seen in other talks. Also, yeah, it enables GraalVM native binaries, which are very hard to do for anyone who's tried it, like without a framework. It's really hard to do, but with Quarkus, it's just a breeze.
Cool. But then I guess if you've got a normal framework and then you put it on top of your cool Quarkus stuff, what happens?
Yeah, so that's a very good point. You could do nothing and like just let the framework do whatever it does, but that would in some ways negate your experience, because maybe that framework is doing class path scanning on its own. Maybe it's like parsing all this XML or YAML or JSON, whatever, or maybe it's creating dynamic proxies. All that stuff is what we've worked very, very hard in Quarkus to remove, right? All the reflection, stuff like that. So a lot of the times you would want to go the extra mile, especially if this is like a very important use case, to enable the type of work we've done in Quarkus, to enable it for your custom library or framework.
Cool. So then I guess, yeah, when we bring in the framework, we're back to this bit where we've got everything at runtime.
Exactly, yeah. This is basically the steps we just described. Yeah, you can see them again.
That's a bit tedious.
So yeah, if we initialize a build time, the result of all the work we do is that we do a lot of this stuff, a lot of this work once, and that's at build time, instead of, let's say, if you're running in Kubernetes and you need to scale like to 100 pods, you don't want to do like 100 class path scans for each pod. Sorry, you do it once. You get rid of a lot of additional code, for example, for parsing XML. You don't need that because that's already done at build time. Obviously, we start a lot faster, use less memory, and lesser node of reflection, which is like on its own, it's not like a huge goal, but it results in better runtime performance and footprint.
Cool. Yeah, and then you've just got that tiny little bit at runtime.
Exactly, yeah. We're starting threads, like reading files, whatever.
Cool. And I guess there's another side to it too, which is that with Quarkus, there's that fast footprint, fast startup, small footprint. But then there's the developer experience as well. And it's not just a developer experience, it's proper full-on developer joy, right? And I don't actually know if this is what happened. I wasn't there at the start of Quarkus. But I sort of imagine that someone said, you know, we've done all this work to make it work with native. We've got like so into the bytecode, and we've moved everything to build time. While we're doing all this work, couldn't we make coding easier? Couldn't we get rid of all this boilerplate? And so then what we've got, the sort of, like we talk about developer joy, and that's kind of generic, but there's some really specific things that we do. So there's the dev instances where when you're coding, it just magics up something for you to code against. And you've got that config, so that instead of having your config scattered across a different file for each framework, is all in one place. And then you've got all these opinionated shortcuts as well, so the boilerplate just goes away if it's not adding value. So like if you're using Hibernate, for example, normally you have to make this persistence XML. And the reason you have to make it is because it would be really annoying at runtime to scan every single library to see if it might have some annotations. But since we can do that at build time, you don't need the persistence XML. And you see this sort of everywhere. And I sort of like to think of it as, it's like it's dynamic in terms of the user experience, but in terms of the performance, it's like it's static.
Yeah, it's static because at runtime, all this stuff is found once, and it's not reinitialized like every time. You can't, in almost every case imaginable, you don't like generate classes on the fly based on user input or stuff like that. Or you don't expect a user to provide like a persistence XML file posted in a form or something like that.
Cool. And so then, like, as another example, if you're doing Cassandra, normally you'd have to do all that, and you'd have to sort of get your cluster builder, and then you'd have to do it, and then you'd have to remember to close it. If you're using Quarkus, you can just inject it. And I think what I really like this sort of phrasing that, what it's doing is it's being opinionated, but it's also being educated because it can see what you've got, so it can make good choices. So then that's sort of for extensions in general. Hopefully that's a pretty good set of reasons of why they exist, why they give value. So you get, if you're wanting to run in native mode, you probably need an extension to even make it work at all. If you're running on the JVM, you're probably going to work without the extension, but it's going to be a lot faster and a lot smaller if you've got the extension.
Absolutely.
And then if you want that good dev experience, there's something that, as an extension writer, you can do to get there. And so because of all those reasons to have extensions, there's a lot of extensions. So if you go to code.quarkus.io, and you sort of look to see what you might want, you sort of scroll down and 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 scroll down, and then you keep scrolling, and then you realize you really should have put in a filter because there's a lot in there, and then you keep going, and then oh yeah, you got to the end. And of course that's just for the sort of the main platform. If instead you want to look at the third-party extensions as well, then there's even more. So if you change your filter, we've got
a whole bunch more.
A whole bunch more. So with so many extensions, is there even any point to this talk? Because there's a lot of extensions out there. Surely the world doesn't need another extension.
Well, I don't know. The new boss has pretty particular needs, so.
Yeah. And so I guess, if your favorite library doesn't have an extension, then maybe one should be written. Or if you are a library maintainer and there's no extension, then maybe it's worth looking into having one. Or as well, if you've got something where you're not really intending to give it out to the community, but just in order to make your build environment work, in order to make your development environment work, you need something that's particular to you, then an extension can be a really nice way of doing it. So as an example, we've got a Zulip forum where people ask questions, and someone asked recently, is there a way to hook a build step? Because I'm doing UI development, and I'm sort of having to do these two things every time, and it's kind of annoying to have to do the two things every time. And the answer in this case was, yeah, we all agreed that was annoying, so we already wrote the extension. You can go look at it. But I think if that hadn't been the answer, then an extension would have been a good way of doing some of those sort of build customizations.
Absolutely.
So if writing an extension is a good idea, then the next question is, how does one write an extension? We're going to do a demo. But I want to run.
We're going to try to do.
The technology is working so well. What could possibly go wrong? We're going to try and do a demo, but I want to run through some of the concepts first before we actually show the code. So the first one is deployment and runtime. All extensions have a deployment part and a runtime part. This is really just the build phase and the startup phase. So just like Quarkus, it's got its deployment phase, it's got its runtime phase, and what we try and do is we try and get as much as possible from runtime to deployment by turning it into bytecode. The extension should be doing the same thing. So get as much as possible from runtime to deployment by turning it into bytecode. And so then some of the things that you should be doing at deployment is go through, understand the app, convert any annotations that you find to bytecode, and then do some of these optimizations that become possible because you understand the whole system. The next important concept is build steps and build items. So when you're writing an extension, the first thing you'll do is you'll define a whole bunch of build steps. And each build step will have inputs and outputs. The inputs and outputs always take the form of what's called build items. And what happens when your extension runs is that the framework will take this sort of big pile of build steps, which define input build items and output build items, and it will magically order them, because it can kind of see, well, this goes into this and comes out of that. And then it will wire them together. And so those build items are the communication mechanism between the build steps. And there's some build items that run at the beginning, and there's some build items that run at the end, so things like making it into a jar, generating a resource. Most build steps run in the middle. And if you're writing an extension, it's those kind of build steps that you're probably looking at, unless you've invented some new form of packaging or something like that, which is possible. So when I was learning to write extensions, one of the things that I was sort of a little bit, it took me a while to sort of figure out, is all of these build items, do I write my own? What do I do? And I eventually worked out that there's basically a library of build items, and almost anything you would want to do in your extension is probably already covered by an existing build item. So what you just need to do is find the right build item and then chain it together with whatever the right thing is for your extension. And to find the right build item, it's on the web, of course. So there's a page that we've got a link to where you can just go and you can just browse what the build items are. And there's a servlet build item, there's various kinds. Next important concept is the index. So the index is all of the classes that Quarkus knows about. And what it supports is if we make the index of all of the classes that we know about, we don't need to scan the class path at runtime, which is a very good thing. In Quarkus, that index is called Jandex. And the reason we have to have the index is because Quarkus operates in a closed world. So if you have an open world, it's really, really hard to do that build time optimization because you don't know what's going to happen at runtime. If you have the closed world, it's easy to do the optimization, which is why we do it. But in an open world, if something just comes onto your class path at runtime, there's no problem. If you've got a closed world and something comes onto your class path that you didn't know about at build time, it doesn't exist, which could be a real disappointment to the person who is hoping to use that class. And so that's why we have to have the index. And one of the things that you can do with your extension is you can add these extra classes that maybe Quarkus didn't know about for whatever reason. You can use an additional being build item, get them into the index. And I think the final concept is bytecode recording. Because in Quarkus, we want to do a lot of bytecode manipulation. Hands up who wants to write ASM. Yeah, OK, so there's a couple of weirdos who are on the Quarkus team. But luckily for us, they're on the Quarkus team. For the rest of us who really, really don't want to write ASM, what you can do is you can just write a class that does the thing that you want to happen. Quarkus will play that, watch what happens, and then replay that at deployment time. And it's called a recorder. We've got an example of a recorder here, but we're going to show it in the demo, so I will skip quickly past. Oh, and the last concept is configuration. So Quarkus, it's got its deployment side, its runtime side, and then your extension has those two as well. One of the nice things is that configuration for all of them comes from the same place. So you've got this application properties, and then you can just add whatever you want in there, and then it's accessible to your extension. And so with that, I think we can show some of this. Well, we can try to show some of this. So we're going to sort of do a laptop switcheroo as well. Because it turns out, if you take someone who's used to Linux and you tell them, can you do a demo live in front of lots of people on a Macintosh, it's not as easy as you would think as a Macintosh user.
Yeah, I at least maybe other people can do it. I can't.
No, we spent a little while this afternoon going, what's this command key, and where's the control key, and why does nothing work? And then,
OK.
Yeah.
So let me get some water, because this is going to be tough. OK, it's going to be tough for me because I don't have the code in front of me. So whatever you see here is what I'm seeing. I don't have a screen. OK, so what we said earlier, excuse me? Oh, I think. What we said earlier is that what we want to do is we want to take like generic applications that you've written in Quarkus, and we want to make them observable in this unique way, right?
Unique.
Yeah. So the idea is that originally we have a Quarkus to-do application, which is a very simple application. It's just has a JAX-RS endpoint, and it just serves a to-do list. It uses a database, and it has a UI, and we'll see how it does. But it's just a generic Quarkus application, right? And we want to instrument it in a way that, like when supposedly when we want to when a get a HTTP REST endpoint is called, we want to like do something like, let's say, log something special in the console, right? We want to say that this method was called. Just for starters, that's what we'll do. We'll say like when HTTP get method was called, then we'll just print on the screen that this was called, right? That'll be really simple because like boss man wants to see something simple first, and then we'll get to the more important thing that he wants to see. So what do we do, right? Because Holly said earlier that we had like 300 applications, right? So we need an extension, which we want to develop and then just plug into the application and have it just work magically. So what we've done here is that this already has the extension ready. It's already configured inside, or it should be configured somewhere. Okay, so we're calling this extension whatever, demo, Minecraft, or whatever. So it's already plugged in, but it doesn't have any code yet, right? So let's start writing some code. So what we want to do is initially we want to intercept the logs, right? So what are we going to do? We have a deployment module and a runtime module, as we said earlier, and we need to split things out. So we're going to start by writing some code for the deployment part, and what we're going to do initially is say demo processor. We're going to go feature. We're going to go build item. Oops, wrong. As we said earlier, we need to create build steps. So build step, and it's going to be public void feature. And we're going to, oh, not void, sorry. This is a feature build item.
There's a nice, if you're writing your own extension, there's a nice little Maven plugin that will scaffold it all for you. So it will create the POM, it will create that file structure, and it will create this first thing that George is struggling to type because he's having to do it turned around to do the first build item. Okay, so yeah, this is just going to be printed on the screen of the application like when it starts, right? So that doesn't do anything. What we really want to do is, say here, we want to intercept the logs. So what we need is a log handler build item, right? So this is going to allow us to create a log handler that will do whatever we want with the logs, right? So we'll go build step, and this is going to be executed at runtime. So we're going to say runtime init. There's a lot of details here, but you don't have to worry about it for the time being. We'll just say that what the important thing to note here is that this part will run as part of your application, not on static runtime, but like when the main, let's say your public static void main runs, which is generated by Quarkus, by the way. But that's not really important. So what we need to do here is we need to find a way to return this build item, but let's see what it takes. It takes a value of a runtime value, which means that it's produced at runtime, and it's optional handler. So we need to find a way to actually see how we're going to get that value. So we need to go to the runtime module, and we're going to say demo log handler. And we're going to call this a recorder because we're going to mention that this is a recorder because, as we said, we need to make Quarkus do some bytecode generation here. We're going to return the thing that we were expecting earlier, which was the optional
of log handler. No, sorry, it's not log handler, it's handler. And I'm going to call this log handler. Okay, and so we're going to return, actually, this is where we're going to need a class, right? Runtime value optional of, we're going to need a class, we're going to call it a new demo log handler. So I don't have this class, but we should get it generated for us, hopefully. No. No worries.
It's amazing how IDEs fail to cooperate.
No worries.
When people are
We'll
watching.
just do it the hard way. Can't create. Oh, sorry. Yeah. This was supposed to be called recorder. That's why I can't. Yeah. So it was my fault, not the IDEs. Recorder. And then this will be called handler here. And now, there we go. See,
Yay.
I was dumber than the IDE. This will simply extend the JDK's handler, log handler. Where is it? Java util logging handler, yes. And we just want to override the publish method, and what we're going to do here is say, we're just going to do, for this, at this point, all we're going to do is system out, and we are just going to say demo, and we're going to print the actual record, which we'll get by saying log message is string format record get message and record. Oops. Good thing I have all the shortcuts because it's pretty hard to type like this. Okay.
For Georgios' next trick, he's going to do the whole demo blindfolded.
Okay, so I think we're good here. For this part, all we're doing is like we're intercepting the log messages, and we're just going to write the same message, but with this demo thing up front, right? So we have our logging recorder. It's actually creating this handler. Excellent. And what we do now is here we're going to need this recorder. So we're going to say demo log recorder. We're going to call it recorder. And we're going to say here log handler, and this should work, I hope. Okay, we already have the build step, we already have all that stuff. Excellent, we already have it here, blah, blah. Okay, so now let's let's package the extension to make it available locally. Oops, where am I? Yeah, anyway.
And so normally if you're developing an application on Quarkus, it will hot reload. If you're developing an extension,
yeah, that's the problem.
it's not optimized for the extension.
You don't get as much Quarkus love, but
yeah,
it's okay. Now we need to start the test application, which I said, as we said, it's just a to-do application, but it needs a database. We could have used dev services here, but let's just oh wow, yeah, okay. MBN Quark, all right, making it even harder. MBN Quarkus dev, okay. So let's see. Now what I'm hoping to see wasn't that, obviously. So what's the error, blah, blah, blah. Let's see what we're doing here.
Oh, we did have some of the logging coming out, though. I saw the eye catcher for it.
Now this is going to be hard to get to the class not found demo. Oh wow. Oh, I know what the problem is. Okay. Yeah, the problem is that I hadn't cleaned the previous thing. When I was doing the demo run of the trial, I had all the code in there already written, and now like Maven's not smart enough to delete the code that you've deleted. So we need to clean manually. That's for people who say like you should never run Maven clean, which is absolutely false. There are
I think
cases.
the lesson is that you should never practice your demo.
That's a good lesson, yeah. Okay, so let's see where we are. Yes, excellent. So every logging we had is now prepended with this demo thing, right? Which is exactly what we wanted.
Cool.
And let's see the local host. Let's see the application itself. So yeah, this is just a to-do application. It was logging like redirect somewhere. So yeah, we just intercepted it and said demo, right? That's not too interesting, is it?
No, I mean, we're only seeing the logging that's already there. What if I forgot to add any logging? What if I want to see what's happening with my application?
So the idea is we'll probably want to ship it somewhere, right?
Yeah.
Okay, so what we'll have to do is let's start by saying, okay, let's create a client, Java class, demo log client. So what this will do basically is we'll ship it. We'll be using like a REST call that, let's suppose there's like a REST service somewhere that
My
is
observability solution.
the custom like in-house observability solution, and it's very simple. All it does is like have 3 endpoints where we ship logs to it or events or something like that, right? So we want to create a client. I'll do this very manually.
Lesson 1 of the cloud is you've always got to send your logs somewhere else other than localhost.
Or somebody's going to be really unhappy. So now here's the configuration for our extension, right? So Holly mentioned earlier that extensions usually need to be configurable in order to like be general for a lot of applications, right? So since we're writing this extension, we want to make sure that it can be used in different ways. So like if our observability solution like moves to some like other URL, we want to make sure that it continues to work, right? The extent the applications can continue to work. So, oops. So what we're going to do here is we're just going to say public string. If I could type string, that'd be cool. String base URL, and I'm just going to say whatever for now to save time. Demo client. Okay, so we're going to use this configuration here. And we're going to get it. Quarkus is going to inject this configuration. Oh, sorry, not log client, log config. Demo config is what we called it. Okay, fine. Demo. Config. Excellent. Okay.
Well, I think you need to go to touch typing lessons.
Okay, let's see. Config. Cool. Okay, so Quarkus is going to allow us to inject this configuration that we wrote earlier via CDI, right? So that's super useful. So we have constructor injection here, which is super useful. And I'm going to use the JAX-RS client. So I'm going to say private final client, which is the JAX-RS client, and I'm going to say this client is client builder, new client. Excellent. Right. Okay, so what do we want to do? Basically, we want to add a method that will just ship the log, right? That's
Cool. Yeah.
our initial goal. So let's call it log string message. And we are going to use the client. Actually, I have no idea how much time we have.
So we've got 5 minutes, 6 minutes.
Oh, wow. That's cool. Okay, so we're going to say client, target, config, base URL, and request media type. It's going to be a text. And this is, the logs are post, I think, right? Yes,
Yeah.
post entity text message.
Yeah.
And that will just ship it off. I'm not going to care about the exception at this point. Also, what we want to do is, though, we said earlier that we want to intercept the GET request, right? So let's go ahead and do that as well. And the way we're going to do that is by adding a public void event method here. Event. And let's just copy and paste this for now. And we're going to say, we don't have a path.
I think we missed a path in there.
Yes,
yeah.
yes, very true. We missed the path here and here. Path is log. Okay, so this is request, blah, 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 but this is going to be a get. No, not there. Definitely not there. Get class. All right, I can't see anything, but that's cool. String dot class.
Cool.
Okay, home. So yeah, now we're going to need introduce local variable, event, okay, S out, demo, event response, event. Okay, so that's just going to be the client shipping off. This is shipping off the interception of the GET request, right? But we haven't actually done the interception of the GET request. So we're going to use a CDI interceptor, which we're going to go call demo. Oh, sorry, this is Java class. Demo log interceptor. It's going to be a CDI interceptor. So interceptor. Oh, we still need the annotation. We need an annotation that will allow us to use this interceptor. Demo log. It's an annotation. I'm pretty sure I have all the cool stuff that we need here. So yeah, this is just basically the idea here is that any method that's annotated with demo log we'll call the demo log interceptor. But there will be no method annotated with demo log. What we'll do is that we will magically add the annotation to methods that are annotated with get, right? That's the big idea.
So rather than having to go through and add an annotation to everything in our estate, which would be really tedious, we can just say, I want everything intercepted.
Exactly. So there's 300 applications. We don't want to have to go everywhere and say like demo log. We want to magically add it, right?
Yeah.
So demo log, excellent, and we'll say public object around.
I think it's a round invoke. Oh no,
the round
that's
invoke.
the annotation.
Yeah, exactly. Invocation context get method. So we're getting the method here that we are going to use. We're going to say s out demo intercepting method get name. Yes, excellent. And now we're going to ship it off. We need to ship it off to our custom observability solution, and we'll do that by saying private final demo. We're going to reuse the demo the client we have, and again, this is CDI enabled, so we'll use constructor injection. We're printing it, and then we go demo client, and say client dot event. Excellent. Cool. So we've written that part, right? Or I think I'm definitely missing something.
Do we need to do anything to the processor?
Yes, yes, we do. But before that, I need to figure out what the error is here because, excuse me? Ah, yes, I'm not returning. You're right. Very correct, yes.
And I think you need to do proceed as well.
Yeah,
don't
yeah.
you?
Context, proceed. And I need to throw the exception. Fine, yeah. So it's just a CDI interceptor that will offload, will hit our observability solution and we'll proceed, right? So now we, exactly as you mentioned earlier, this code is not really knowable. Quarkus doesn't know about it. So we need to make it known to Quarkus. And we'll do that by adding public, as you showed earlier, the additional bean build item.
So is this adding stuff to the index?
Yes. It's adding stuff to the CDI index to be precise, yeah. And oops, there's a builder here, and we will say add bean classes. And which bean classes do we need? We want the client, the demo log client class, and the demo log interceptor class. Excellent. We'll make these unremovable. So Quarkus also has this notion of that it removes CDI beans when it thinks that they're not used. So that saves a lot of space and a lot of memory and startup time. But we need to, in this case, we need to tell it that the demo client and the log interceptor are being used. Okay, so we've done that, and now here's the real magic. The real magic is, like we said, we wanted to make the JAX-RS get annotation. We wanted to let's say change the code. So every time we see a get annotation, we want to add the demo log annotation, right?
Cool.
And Quarkus has this amazing build item that does that, which is called a annotation build item transformer. So what that does essentially is that it allows you to make arbitrary annotation transformations on CDI beans. So we will just add a transformer here, and we will say if transformation context get annotations stream any match AI, not AI as we hear it in the news, but it's good enough for this particular instance. AI name. So we basically want to make sure that we're only transforming things that are the JAX-RS get, right? So get class, get name. So if we find the name annotation, what we want to do is, oh, right, yes, very correct. Dot name create simple. Thank you. Okay, here we go. Transformation context, we want to go ahead and transform it by adding the demo log annotation, and it's
Was it the demo log interceptor?
no, the annotation. We want to add the annotation because the interceptor gets added automatically when ARC figures out what's going on. So yeah, I think we're not good here because we need this because we're in Java and not like Kotlin or something. What? Excuse me? I can't hear you. Done. Oh wow, yeah. Oh, that would really mess things up. Yes, done. Thank you very much. Okay, now let's see if this actually works, right?
Cool, yeah. We're 4 minutes over, so we have to hope that it works or we're in trouble.
Yeah, or else this is for nothing. Okay, so what I want to do, basic, oh, wow. You know what else I forgot to do? I forgot to start the magic part, which is this. Okay, so let's see where we are with the application. Okay, the extension got installed, and now we need to restart the application because obviously, you got a glimpse of our custom
Yeah, so what
observability
is this
solution.
observability client?
So yeah, well, you should explain the use case more since it was the boss who requested it.
Yeah, so I think the boss has the mental age of a 10-year-old, and everything has to be surfaced to him through Minecraft, which is unfortunate because we have 300 applications to instrument to do Minecraft as an observability solution. Basically, if it's not in Minecraft, it doesn't exist for him.
So yeah, basically he wants to see when our applications are hit. He wants to see something happening in Minecraft, right? Which is pretty weird, but you know, people. And yeah, I messed up. I didn't say where our observability solution is, or the default is basically. Localhost 8081 observability.
Oh, I don't think that's right.
No, yeah, you're right. Observability. Okay, hopefully this time we'll do better. Excellent. So the application is starting. Yeah. Oh, you gotta be kidding me. I had done.
It's not like you just had this up.
Yeah, it's not like we just tried it earlier, like an hour or so ago. Wow. Well, at least the Wi-Fi is real fast.
Yeah.
Excuse me? You know what? I've never touched Minecraft before this demo. So I knew what it was, but that was about it.
And see, now you're never going to touch it again.
Yeah, since it messed with us so much. Okay, where'd it go?
I think there's like a pause, and then it'll sort of come
okay.
back, hopefully.
Woo.
Yay.
Weren't we at 118.2 just like an hour ago?
Oh.
In the space of an hour, it updated. Yeah, that's wonderful.
Cool. No.
Of course. Please use 118.2. Thanks. Yeah, sorry about that, but I just tried it. We just tried it an hour ago. I mean, it's insane.
Right, now's when, no, I think we're not going to have time because we're 8 minutes over. That's so sad.
Sorry, we're really sorry about this. But
yeah, the lesson is that you need to go somewhere that doesn't have network so it doesn't do the update.
Yeah, I mean, I can't believe this. This is, you usually want Wi-Fi to be working. In this case, I guess you don't. Anyway, so you want to finish here with?
Yeah, I think we can just really sadly explain what you would have seen. Oh, it's so sad. I'll post screenshots because it was really cute. What you can see is you can see all the Quarkus logging coming out in Minecraft. So you see it listing what extensions it does and stuff. And then when you hit the REST endpoint, it does a lightning bolt, and then it spawns a chicken. And the chicken shows the timestamp. Because if you were doing it in production, obviously, you wouldn't just show the timestamp. You'd have something like the IP address of whatever was hitting the endpoint. But because this isn't production, we just put the timestamp on the chicken. And if you get an error, the chicken explodes. And then it sometimes... The problems that we thought we would have with the demo is that the exploding chicken sometimes kills you if you're too close to the chicken, and then you have to respawn. But we didn't anticipate that Minecraft would update itself and lose its compatibility.
Yeah, we need to keep that in mind for next time.
Yeah, and the last thing that we we haven't talked about is if you want to do something to make it work with GraalVM, you might need to go a little bit deeper. You might need to do some substitutions and telling it about reflection and that kind of thing. But that's all documented if you do go that far. So with that, thank you very much. I'm really sorry we didn't get exploding chickens. And thank you very much for your attention on the last day of the last session.
Thank you for coming. Any questions? We're available probably like after because we're already over time. Yeah. You want to come make Minecraft work?
Yeah, yeah, I can do it. I've probably got it on my machine.
Yeah, go ahead.
Right.
Oh.
Any questions? Is that a question at the back, or is that someone stretching? Someone going, I'm sure there's beer. Please let me go. Yeah, I think we better let everybody go.
Okay.
If anybody does want to see it, I'll get it up, and we can show it without everybody waiting and watching and wishing we were beer. So thank you all again.
Thanks again.